thing you have to do for this reaction is to translate the words into formulas. And you translate the words into formulas by doing the same thing that you have always done, by referring to your common ion sheet, your periodic table, in order to find these ions, balance charges, and then write out the neutral formulas. Okay? So here's what I like to do. I like to write the ions on the top before I balance. So ammonium from your common ion sheet is NH4 plus 1. Sulfate from your common ion sheet is SO4 negative 2. So you can tell that a plus 1 and a negative 2 needs to be balanced by multiplying the ammonium by 2. So ammonium's transcript, I mean not transcript, subscript is going to be 2. Okay? So we got NH4 2 SO4 for ammonium sulfate. And then my second compound is barium nitrate. Barium is plus 2 from the periodic table. It's in the second group on the periodic table. Nitrate is minus 1 from the common ion sheet. So we need 2 nitrates to balance out the barium's plus 2 charge. So my compound is now barium nitrate. Okay, NO3, 2. The multiple becomes the subscript. Now, if you guys remember, both reactants in double replacement reactions are aqueous. So this is going to be AQ, AQ. Now I have to write what my products are. Before you can write the products, you need to do AX plus BY. We know they are going to AY plus BX. Okay? Now, here's the nice thing about the translating. We already have all of the ions that are going to be mixed up. So we already have the charges written down. We know A is ammonium and Y is nitrate. So ammonium's plus 1 charge and nitrate's minus 1 charge is going to go 1-to-1 ratio, and your your compound is going to be ammonium nitrate. So NH4 NO3 is your first AY compound. And then the second compound is plus 2 from barium, negative 2 from sulfate, plus 2 minus 2 cancel out. Your second compound is just going to be barium sulfate, Ba parentheses SO4, close parentheses. Okay? Now, what you have to do is figure out which one is your precipitate. But before we do that, we should balance our compound. So on the reactant side, I have two ammoniums and 2 nitrates, which means I have to put a 2 in the front of ammonium nitrate, and now we're balanced. Okay, so let's figure out our precipitate. First thing, try to see if you can find ammonia on the solubility rules. You have to look on the left of the solubility rules, whether it's in the blue or orange table. So I spot ammonia right here. On the blue table, ammonium, sorry, I keep saying ammonia. I spot ammonium on the blue table on the left side. Ammonium is always soluble, no exceptions, which means ammonium nitrate is aqueous. Now we gotta look for barium. I don't see barium on the left of any of the blue or orange table rows. So I look for sulfate. I found sulfate right there. Sulfate is in the table where most things dissolve, and we have to check if barium is an exception, and it is. Barium stops sulfate from dissolving, therefore barium sulfate is my solid. Okay? Left to right is how you're reading your table. Okay, now, second one, lead nitrate and sodium chloride. So lead 2, that tells me that this is Pb plus 2. Remember, the Roman numeral is always the charge. Nitrate is NO3 minus 1 from the common ion sheet. Sodium, Na plus 1 from periodic table. Chloride minus 1 from group 17 on the periodic table. Okay, we're ready to form our compound. We got Pb plus 2 and nitrate minus 1, which means I need 2 nitrates here for my PbNO3, 2, plus sodium and chloride, 1-to-1 ratio, just NaCl. Okay, now I'm going to form my AY and my BX. A is lead and Y is chloride. This is A, X, B, Y. So A is lead with a +2 charge, chloride is -1, which means I need 2 chlorines to form my compound PbCl2, plus sodium is +1, nitrate is -1. I just need NaNO3 as my second compound. 1-to-1 ratio then, okay? Remember to always write sodium first because cation must always come first. All right, now let's balance. I got 2 nitrates on the reactant side, and I only have 1 nitrate on the product side. Put a 2 there. And since that changed my sodium number, I got to put a 2 there. And that balances out with my chlorine. We good. These are easy balancing, but remember, do as I say, not do as I do. I want to see your work for balancing in any quiz situation. Okay, let's figure out our products, which one is the precipitate, or if there is a precipitate. So scan your products for an alkali metal. I spot sodium. Sodium is an alkali metal, always soluble, no exceptions. Therefore, sodium nitrate is aqueous. Let's look at lead chloride. Check for lead on the left of either table. I don't see it, but I do spot chloride right there. Chloride generally dissolves in water, usually, but is lead a exception for chloride? Yes, it is. Lead stops chloride from dissolving in water, and therefore this is your solid. Okay? Remember, the blue table always dissolves in water unless faced with an exception. Exception stops it from doing what it usually is supposed to do. Okay? All right, let's look at the next one. I have sodium, Na+1 because group 1, phosphate, PO4 with a -3 charge. I found that in the common ion sheet. And then I have potassium, group 1+1, nitrate, NO3 -1 from the common ion sheet. Okay, now I spot, when I write my compounds, I'm going to need 3 times the sodium because phosphate is -3. Na3PO4 is my first compound, plus KNO3 is my second compound, 1-to-1 ratio. Now, before I even write my products, I spot that my first reactant is made up of an alkali metal. My A is an alkali metal, and so is my B. If A and B are alkali metals, right? This is AX plus BY. My new compounds are going to be AY plus BX. If A is an alkali metal and B is an alkali metal, that means both products will start with an alkali metal, and alkali metals are always soluble, no exceptions, and therefore you don't even have to write anything. This is a no reaction situation, no products required, because we know A and B are both alkali metals, and that therefore both products will be aqueous. Okay? Now, next one. We have sodium, Na+1, bromide, Br -1, rubidium, Rb+1, Cl -1. Oh, I see something happening here again. We got NaBr +1 -1 plus RbCl +1 -1. But look, alkali metal, alkali metal. A and B are both alkali metals. Again, no reaction because for both of these, oops, supposed to be a curly bracket, both products will be aqueous. In both these situations, because they both will start with alkali metals. So in that situation, don't even have to write any products. Okay? Now, I believe this is the last one, or is there one underneath that I didn't scroll to? No, this is the last one. Okay, so we got copper. It's copper too, so I know it's +2. And chloride with a -1 charge from group 17. Sodium, Na+1, hydroxide, OH -1 from the common ion sheet. All right, Copper is +2, chloride is -1. I need two coppers to balance out two chlorides to balance out the copper. So my formula is CuCl2 plus Na is +1, hydroxide is -1, 1-to-1 ratio. Formula is just NaOH. Okay, now I'm ready to write my products. This is AXBY. All right, we got copper going with copper +2 going with hydroxide with a -1 charge. That means I need two hydroxides to balance out my copper's +2 charge. Plus, I have sodium with a +1 and chloride with a -1. That means my compound is just NaCl. For some reason, if you wrote NaCl2 because you copy pasted the subscript from the copper chloride, that was wrong. Fix it. Don't do that again. Okay? I'm stressing it so much because people do it all the time and it drives me nuts. Okay, so we got NaCl. Sodium is an alkali metal, always soluble, no exceptions. Gotta say that it's aqueous, but whoops, Mrs. J is skipping along too fast. Gotta balance this equation. We have two chlorines on the reactant side. Got to put a 2 in front of sodium chloride here. So that means I got to put a 2 in front of the sodium hydroxide and be good. Okay, let's check to see if copper hydroxide is a precipitate or aqueous. So try to find copper on the blue table. I don't see it. Try to find hydroxide. I don't see copper on the orange table either. Try to find hydroxide on the blue table. It's not there, but it is down here in the orange table. And if it's in the orange table, that means hydroxides don't usually dissolve. They are generally things that don't want to dissolve. So let's see if copper will make it dissolve. I don't see I don't see copper as an exception for hydroxide. Okay? The only exceptions are alkali metals and also calcium, strontium, and barium, and those are not copper. So copper hydroxide is my solid, and we're done. Okay, so review your single replacement and review this worksheet and the answer key and the answer video and be ready for a quiz on Tuesday or Wednesday. All right, bye peeps.